Good morning, everyone. So now we are moving on to multiplying complex numbers. So we did adding and subtracting, we did quadratic formula, so now we are going to multiply them. Okay, so today instead of doing a SAT question, I decided to do an AccuPlacer question. So the AccuPlacer is a test you take when you get into your college, and it's for placement. So what math class do you belong in based on your knowledge? So here's an example. So again, a lot of it is very Algebra 2 based. So pause the video and solve that problem. So it's a quadratic because it's an x squared. So x squared plus 5x minus 9 equals 5. I'm going to subtract 5 on both sides. X squared plus 5x minus 14 equals 0. That's just a regular MC chart. Multiply to negative 14. Combine to 5. 1 times 14, 2 times 7. So we know it's 2 and 7, but who's going to be negative? The 2 is negative to give us a positive 5. So x minus 2 times x plus 7 equals 0. Set each of those equal to 0. So x equals 2. X equals negative 7. So which one of those is an option? D, negative 7. That's it. So pretty straightforward. Okay, so we talked about this yesterday. So I, what is I equal? Who remembers? I is the square root of negative 1. Okay? I is that imaginary number, the square root of negative 1. And that's kind of like its definition. So now here's the question. What would be I squared? So if I square the left side and square the right side, what happens to a square root and a square? They're inverses. They undo each other. So we just get negative 1. So I squared equals negative 1. Right? That's really important. I squared equals negative 1. Okay. So we know that I squared equals negative 1. What do you think I to the third equals? So this is a little tricky. So I to the third, let's break this apart. That's I times I times I, right? Anything to the third power. So if I group these two together, that's I squared times I. What did we just said that I squared is negative 1. So negative 1 times I is negative I. So that's our answer. I to the third equals negative I, right? So I squared is negative 1. I to the third is negative I. All right, so I want you to pause the video, see if you can figure out these other three. All right, I to the fourth, I squared, there's 4 of them, right? So I times I times I times I. So how do you think we should group this? So I'm going to group 2 and 2, right? Because I squared times I squared. I squared we know is negative 1 times negative 1. What's negative 1 times negative 1? 1. So that means I to the fourth is 1. I to the fifth. So I to the fifth would be I squared, I, right? 2 plus 2 plus 1 is 5. So that's negative 1 times negative 1 times I, which is just I. So I to the fifth is actually the same thing as I to the first, right? Because this is the power of 1, right? I to the first is just I. What do you think I to the sixth is? So notice I keep doing I squareds. I squareds are that's not what we normally would do. What do you think would be easier than I to the I squareds? I to the fourth. Since I to the fourth is 1, negative 1. What I would do is rewrite this as I to the fourth times I squared. 1 times negative 1 is negative 1. So I to the 6th is exactly the same as I squared. What do you think I to the 5th was the same as I to the 1st? What do you think I to the 7th will be the same as? This. So notice every 4 i's we kind of start over, right? Every 4 i's we start over. So this is like the key here. Right? So I to the 1st is I to the 2nd is negative 1, I to the 3rd is negative 4, I to the 4th is 1, and then let's add in, I don't have room up top, but what would be I to the 0? What's anything to the 0 power? Anything to the 0 power is 1, right? So this is kind of our chart that we're going to use pretty regularly. So keep in mind, every 4 i's, we just start over. Every 4 i's brings us back. So if I have I to the 32, how do you think we could simplify that quickly? Every 4 i's, we start over and it's 1. Right? So how many I to the 4ths go into 32? So I have 1, it gives me 8, 12, 16, 24, 28, no, I skipped one, 4, 8, 12, 16, 20, 24, 28, 32, and then we're done, right? And then what's I to the 4th? So that's just 1 times 1 times 1 times 1 times 1 times 1 a bunch of times. So the answer is just 1. All right, so that's kind of annoying. Can anyone think of an easier way to do that? What we really need to know is how many times 4 goes into 32. 4, because of all those I to the 4ths, goes into 32 8 times. What's the remainder? What's left over? 0. So that 0 is actually our new remainder. So this was really I to the 0, right? So the key here is we need to divide by 4 and figure out what's left over, because all those I to the 4ths are just 1. So how many times does 4 go into 71? Goes into 7 once. Gives us 31. 4 goes into 31 7 times. 28, subtract, and that's a 3. Now, we don't care about the 17. That just means we have 17 I to the 4ths. What we care about is after all those I to the 4ths, what's left over. So this equals I to the 3rd. Now look in your chart. What did we say I to the 3rd equals? Negative I. All right? All right, 90. So try this one on your own. Divide by 4 and find your remainder. So I'm going to take 90. 4 goes into 90 how many times? Twice, 2. So again, this is, we don't need the 22. We have 22 I to the 4th. I to the 4th is 1. What we need is the leftover. So the I to the 90th is the same as I squared. And then look in your chart. What do we know that I squared equals? Negative 1. Done. All right, last one on this page, 37. So 4 goes into 37 9 times. 1 left over. Again, we don't need our 9. 1 is our new exponent. I to the 1st, that's just I. Okay, so how do you simplify I raised to a power? Divide the exponent by 4 and find the new remainder. The remainder is your new exponent. Simplify using your I chart. So our I chart is our I to the 0 is 1, I to the 1st is I to the 2nd is negative 1, I to the 3rd is negative I. So that's our I chart that we need to have. Okay, what is the difference between an imaginary number and a complex number? I is an imaginary number, and a complex number is the I, but it also has those other numbers with it. So like 2 plus 3i is complex. I is just that. The imaginary part is just the I, all right? So I kind of use them interchangeably though. imaginary numbers and complex numbers, but they are slightly different. But I pretty much use them back and forth. Okay, so I want you to treat these like an x. So what would you get if you had 12x times 5x? 5 times 12 is 60, x squared. But it's not an x squared, it's an I, right? So this is 60i squared. But now, what do we know? I squared equals -1. So then we have 60 times -1. So our answer is -60. Good. So now that you've seen that one, you should be able to go through and see if you can figure out the rest of these. All right, so we've got -42i squared. -42, I'm going to replace the I squared with -1, and we get +42. 2i to the second, that is 4i squared. Again, I'm going to replace my I squared with -1, and I get -4. All right, last one. What is 3 to the third? 27i to the third minus 4 squared is 16i squared. Now I'm going to replace what's I to the third equal to. I to the third is -I. I squared is -1. So we get -27i plus 16. And I like to reverse it because you're supposed to put the I second. Right? It doesn't actually matter. If you put this, I wouldn't take points off. But this is typically how it's written, where the integer first and then the I second. Okay. Now we're going to distribute. So I want you to pause and see if you can figure these out. They're pretty straightforward. All right, so we're going to distribute. That's -32i plus 20i squared. And then again, what is I squared equal to? -1. So -32i plus 20 times -1, -32i minus 20. So either that or, again, I like to write it in the proper order. So that's my answer. So if you watched and you didn't try the others on your own, pause, try them on your own. So we get -30i minus 42i squared. 42 times -1, -30i plus 42. Notice it just ends up switching the sign. I would really prefer you multiplying these out, though. Don't try to guess and don't just put what you think the answer is. Actually think about the mathematics, right? We're replacing I squared with -1, so that flips the sign. All right, last one, distribute. 11 times 12 is 132i minus 99i squared. 132i minus 99 times -1. That becomes a positive 99, and then the 132i. All right, we're going to get a little harder now. So this is double distributing. Who remembers how to double distribute? So we distribute the 4, right? So we're going to do 4 times 9 plus I, and then I times 9 plus I. So remember, we're distributing the 4 to the whole thing, and then we distribute the I to the entire thing. So multiply through 36 plus 4i. I times 9 is 9i plus I squared. So now the middle two go together. 36 plus 13i. But, again, what's I squared? -1. And then what's the last thing I can do? I can combine my 36 and my -1. So 35 plus 13i. So it's just one step harder than regular distributing. because we have to substitute and combine like terms. All right, pause the video and try number 9 on your own. So I have 2 times 7 plus I minus 6 times 7 plus I. Distribute, and I get 14 plus 2I minus 42. Now, don't forget, when you distribute, that negative is going to go with the 6. Negative 6I. Oops. Oh, no. I forgot the I there. I squared. So that was negative 42I and then negative 6I squared. So 14. Put these two together, and that gives me negative 40I. And then over here, I have minus 6 times negative 1, which gives me a positive 6. So then I'm going to combine the 14 and the 6, and that gives me 20 minus 40I. And that's my answer. All right, same exact thing. Number 11, don't forget, 4 plus 3I squared is 4 plus 3I times 4 plus 3I. So pause the video and try these two on your own. So we're going to do 9, 4 plus 7I, minus 3, 4 plus 7I. Distribute, 36 plus 63I. I keep forgetting the I. What is wrong with me? This is 3I. All right, so minus 12I minus 21I squared. Middle two go together. 36 plus 51I minus 21, and then I'm replacing my I squared with negative 1, which makes this whole thing plus 21. So that I can combine the 36 and the 21, and I get 57 plus 51I. All right, this is not 16 plus 9I squared. Do not fall into that trap. 4 times 4 plus 3I. 3I times 4 plus 3I. Don't take shortcuts. 16 plus 12I. 12I plus 9I squared. Middle gives us 24I. This is 9 times negative 1, which is negative 9. Negative 9 and 16 gives me a 7. Oops. So I get 7 plus 24I. Right? I have that 16, and the negative 9 gives me a 7. All right, last page. Same thing, distribute. So I've got, I'll do green, 11 times 11 plus 6I minus 6I. Oh, we remembered the I this time. 11 plus 6I. Distribute. 11 times 11 is 121. 66I minus 66I minus 36I squared. Now what happens to those 66s? They end up canceling out, right? 66 minus 66 is 0. So this is 121 minus 36 times negative 1. 121 plus 36. So notice what happens there. We got an integer. All the i's disappeared. What do these look like? These should remind you of something. These are basically dots problems, right? It's the same thing with opposite signs. So the middle term is always going to cancel. So we've got our 2 times 2 minus 5i, 5i, 2 minus 5i. So again, what should happen here, because it's the same binomial with opposite signs, that middle term should cancel out. 4 minus 10i plus 10i minus 25i squared. The 10s cancel, right? We got a negative and a positive one. So 4 and then minus 25 times negative 1. That becomes 4 plus 25. So we end up with 29. So anytime we multiply those out, where it's the same binomial twice with opposite signs, we actually get an integer that all the i's disappear. All All right, and that is it. That is the lesson. All right. Have a fabulous day, guys and ladies.